Welcome to this video on installing the rock-solid Knowledge FIDO.NET component into OpenIddict. My name is Kevin Jones. So in this video, I'll show you how to install the FIDO component and how we can use that FIDO component within OpenIddict to provide two-factor authentication. So to do this, we'll start with some samples from OpenIddict. And in particular, we'll start with the Volusia samples, and you can find them on the OpenIddict GitHub site. And to these, we'll add FIDO support using the rock-solid Knowledge FIDO component. Now, these samples use ASP.NET Identity to provide the login flow, and we need to hook into that identity to change the behavior. So to do that, we will scaffold ASP.NET Identity into these projects. And once we've added that scaffold, we can change the flow to provide two-factor authentication, or 2FA. So I'm going to start by creating a new solution. And we'll create an empty solution, and then into this, we'll put two projects, and we'll grab those projects from the OpenIddict samples. So I've called my solution FIDO with OpenIddict, and that just opens into a new window inside Rider. The OpenIddict samples are on GitHub, and they're at github.com/openiddict/openiddict-samples. Now I'm going to grab all of these, but I'm not going to use all of the samples. And if we look in the samples directory, near the end, we'll see this sample called Volusia. And if we look at that, we'll find there are two samples in there, a client and a server. And these are the two samples that we'll use. Now, I can't load these two projects directly into Rider or indeed into Visual Studio, as I need to change their CS proj files first. They are set up to be used inside the OpenIddict samples project. So there are some changes we need to make. Notably, I just need to add version numbers to the libraries the project are using. So for the client, it ends up looking like this. So we set the target framework to be .NET 9, and we set version 9 of the various Microsoft libraries, and then version 6 of the various OpenIddict libraries. And then for the server, we do the same thing. So again, we set up the correct versions of the libraries and add the right .NET framework. So with that in place, inside Rider, I can add an existing project, and the first one will be the Volusia client, and the second one, the Volusia server. So before we dive into code, let me show you what should happen. So this is the Volusia client, and the server's also running. So if I sign in here, I'm going to register a new user, and we'll grant authorization, and that also logs us in. Now from here, I can register a new device. And this will let me do two-factor authentication. So I'm going to register a YubiKey that's plugged into my machine. So I click on register, and this takes me off to the OpenIddict server. So here, I can give the device a name. So we'll say Yubi, click on register. I have to interact with the device. So I enter my PIN, touch on the device, and the device is now registered. Now if I sign out, sign back in, when I click on login, I need to do two-factor authentication. So it checks to see that we have a device, and if it does, it prompts me to use that device. So again, I touch the device, enter the PIN, touch it again, and we're now logged in. And that's where I want to get to with our client and our server. So the bulk of the work for this will be in the server project, but we also need to make some changes to the client project, and most of those are around the user interface. So I'm going to add a new style sheet just so we can theme some things on the UI. And this will just allow me to make some of the text in the anchor tags larger so we can see them on the screen. I'm also going to add a new link to the application so that when I click on that link, we require authorization, just to show that will also give us two-factor authentication. So in the home controller, at the end, I'm going to add a new endpoint called privacy, and we add the authorized attribute to that endpoint. So when I hit this endpoint, we'll require authentication and authorization. And we also need to add a view for this. And that view is just going to print out a simple message. So with those in place, I need to make sure my site.css gets used. So in the views shared folder, we have this layout.cshtml. And to that, I need to add a reference to this style sheet. And then finally, I'm going to update the home page. So in home index.cshtml, at the bottom of this page, I'm going to add two links. I'm going to add one link to the privacy page that we just saw. And remember, that requires authorization. And I'm also going to add a link that allows us to register the device. So after I'm authenticated, we click on this link and it lets me register my FIDO device, in this case, my YubiKey. So with those in place, if I rerun this client, it looks like this. So we have our links to our privacy page and we have the links to register. Privacy requires authentication. Now, currently the server isn't running, so this isn't going to do anything. And the style sheet increases the size of the text of these links so we can read them on the page. So before we make changes to the server, let me show you what happens at the moment. Now, currently both the client and the server are running. So for my client, if I click on sign in using the local OIDC server, that takes me off to the server. From here, as we know, we have to register a new user. So let me register myself, give myself a password, and click on register. Yes, we grant authorization, and we register and sign in. If I sign out and click on the privacy link, say, that takes me off to authentication. I click on login, and we are authenticated, and we're at the privacy page. But there's been no second factor here. So it's just done a standard username and password authentication. And that's what we want to change. We're going to add two-factor authentication to this. So the two-factor authentication will be driven from the server, and we'll do it using FIDO. And to do that, we're going to use the rock-solid knowledge FIDO component. So to install that component, I'm going to go to NuGet, and then inside NuGet, I'm going to look for these two packages, the rsk.aspnetcore.fido, and then the rsk.aspnetcore fido.entity framework. And if I select the FIDO package, I'm going to add that to the server, and we can install that. And then I'm also going to add the entity framework package and add that to the server and install that. So the entity framework package will allow me to store my FIDO information in a database. The other option for testing will be to store the FIDO information in an in-memory store. So in my server, in startup.cs, now these projects are using SQLite. And I'm going to make a couple of changes to the SQLite configuration. So first of all, inside the app settings, I'm going to change the default connection string so that it uses SQLite. So we change the text here just to be the name of the SQLite database. And for the server, I'm going to set this to be identity.db. Now we can do the same thing in the client as well if we need to, as that also uses SQLite. With that in place, in my startup, I'm going to specify the connection string from the configuration file. So here, when we say use SQLite, rather than hard coding this path, I'm going to get the default connection string from our configuration file. Okay, so with that done, I need to install the FIDO component. Near the end of configure services, after we call add hosted service, I'm going to add FIDO. So to do that, we say services.add FIDO, and this takes some options, and we use these options to configure FIDO. Now there's a couple of things that we need here. I want to set what's known as the relying party. And we do that by setting this relying party ID. And in our case, relying party is the server we're running on, and that's just going to be localhost. And then I have to set two other values. The first is the licensee, and we'll set that to be demo. And the second will be a license key. So you can get both a licensee and a license key from rock solid knowledge. And I'll show you how to do that in a moment. So my license key looks like this, and it's a demo key. So with those two in place, I then need to tell the FIDO component to use Entity Framework to store its keys. So we do that by calling add Entity Framework store. Again, this takes an options. And in these options, we have to tell FIDO which database to use. So we're going to use SQLite. So that's options.useSQLite with the connection string that we set. And then I'm also going to use this to generate the migrations that we need. So on useSQLite, this also takes an options. So I can say db opt goes to db ops.migrationsAssembly, and then we have to pass this the name of the assembly that we get these migrations from. So we can use type of startup, which is the class we're in, .assembly to get the assembly this class is in, .fullname to get the full name of that assembly. And that gives us everything we need. Okay, so where do we get this license key from? So to get the license key, we go to this website, so OpenIddictComponents.com. From here, if I go to Products, and then go to Fido.net, and then I can simply register. Enter your first name, your last name, and your email address, and we will send you a demo key. And that's what I've done for this video. So the next step is to create the migrations for the Fido component. Now I'm going to run this from the command line. So I'm in the Velusia server directory. And the first thing I need to do is ensure that the entity framework tools are installed. So I'm going to do .NET tool install and then -g .NET-EF. And the -g just says install these tools globally, not locally. Now, as you can see on my machine, the tools are already installed. Once we have the tools installed, we can then generate the migrations. And to do that, we run .NET-EF, migrations, add, and then we give these migrations a name. And I'm going to call these Fido. They need a DB context. We use the -c flag for that. And in this case, that's the Fido DB context. And I'll explain in a moment where I got the name of this DB context from. And then I can tell the tooling where to put these migrations. So I'm going to say migrations/Fido. And if we run this, it will first build the project. And then after the project's built, it will create the migrations for me. And if I look inside my IDE, inside Rider in this case, there's the migrations directory, there's Fido, and there's the migration I've just generated. So once I have the migrations, I can then apply them. To do that, we do .NET-EF, database, update, as we update in the database, and again we supply the DB context, which is Fido DB context. Again, it will build the server, and then run the server to update these migrations. Now we're using SQLite, and SQLite is using this database called identity.db. Inside Rider, if I open my database view and drag the database across and select OK, if we open up this database, we can see that as well as having the ASP.NET identity tables and the OpenIddict tables, we also have this Fido keys table. So these migrations have been applied to this database. So to create these migrations, we use this Fido DB context. So where did that come from? Well, if I was to look at add entity framework store, we see in there that calls add DB context and uses this Fido DB context. And that Fido DB context looks like this. It's a standard DB context. So it derives from DB context and it's just used for this Fido store. So this OpenIddict server uses ASP.NET Identity to provide the user interface for authentication. So things like the login screen and the registration screen. Now we want to change that mechanism. We also want to add two-factor authentication. And to do that, we have to hook into ASP.NET Identity. And to do that, we can scaffold ASP.NET Identity into the project. Now adding the scaffolding takes a number of steps. And those steps are detailed here on the learn.microsoft.com website, so scaffold identity into ASP.NET Core projects. Now the piece of this that we care about is this piece here titled Scaffold Identity into an MVC project with authorization. If you have Visual Studio, there's a set of steps. We are going to use the .NET CLI because we are using Rider, and there are a set of steps for that as well. And the first thing we have to do is add in a set of NuGet packages. And there are a number of these that we have to add. And I just run these here one after the other. So with the packages added, we then need to make sure that the generator tool is installed. And to do that, we run .NET tool install, again -g for global, and this is the .NET ASP.NET code generator. And again, as we can see on my machine, it's already installed. With that in place, we can check that the identity generator is in place by running .NET ASP.NET code generator identity and then -h for help. And that shows us the help for this generator. So it should all be there and ready to use. So given that, I can then run the generator. I can ask it to generate the identity scaffold. We specify an application context. And in this case, this is the application context of my application. So that's application DB context. And we tell it which files I want to generate. And in this case, we only care about two things, and that's account registration and account login. Now, before I run this, if I go back into my IDE and look in the server project inside the areas section, there are already files in here. So I'm going to delete those and make sure we have a clean areas to start with. So I can do that. I can go back to my command line and then run the generator. And if I go back into my IDE, we'll now find inside the areas, we have an identity area and we have the pages. And we have the pages for login and for register, along with some other bits and pieces. And it's these files that we'll need to change. So we have to write some code to register our device with this application so that we can use it for 2FA. But before we write that code, let's understand how registration works. So at the browser, the user will get prompted for some details. And those details in this case would include the name of the device that we are registering. We call back to the server and ask the server to start registration. The server will insert the user information into the database, and then it kicks off the registration process. And when it does this, we send what's known as a FIDO challenge back to the browser. The browser calls an API called navigator.credentials.create, and that interacts with something known as the authenticator. And the authenticator interacts with your hardware device. In this case, that would be my YubiKey. If that interaction is correct, so if the device recognizes me, then it will send public key credentials back to the browser. The browser sends those credentials back to the server, and the server finishes registration and then inserts those credentials into the database. So let's go write that code. So for this to work, we need to do two things. We need to manage the FIDO interaction, so things like registering the device and then providing the second factor when that device has been registered. And we need to change the flow of the application so that if we have a device in place, we ask for the second part of the logon, the second factor. The first part of this, or the FIDO code, we are going to place into a controller called FIDO controller. And for the second part, for changing the flow of the application, we'll need to edit the code that we just scaffolded into the application. So first things first. So inside my application, I'm going to add a new controller, and I'll call this FIDO controller. And this controller will manage all the FIDO-ness of the application. Now remember, the first thing we have to do is register our device. And to do that, I need to provide a method called start registration. So that will be a method that returns an iAction result. And to this, we're going to pass a string, and that's going to be the return URL. Now, I only want this method to do some work if the user is authenticated. So we can say if user.identity.isAuthenticated equals true, then I'm going to return some view. And we'll write this view in a moment. And into this view, we're going to pass a model, and we'll provide that in a moment as well. Now, this view will just present a user interface that allows the user to enter the name of the device that they want to register. If the user isn't authenticated, then I'm going to redirect back to the account login page. So I call redirect, and I pass in the account login URL, and the return URL is start registration. So the return URL comes back to this site. So for the view, I need to pass in a model. So let's go and create that model now. In my view model section, I'm going to create another directory called FIDO. And in here, I'm going to add a class called start registration. And this class will have two fields. One will be a string, and that will be the device name. And this is the name we want to register. And then the other one will be the return URL. So where do I want to go back to? And that will be a nullable string. So for the device name, we can add some attributes. So I want to mark this as required, and I want to give this the name to use on the display. So I'll say display, and in here we can say name equals, and we'll just pass in device name. And then back in the controller, I can create an instance of one of those models. So this will be of type start registration. We can import that. We'll name the variable model, and then we can just initialize that. And in here, I'm just going to set the return URL. And that will be equal to the value passed into this function. And then to the view, I'm just going to pass along this model. So I now need to create the view. So again, in my project, this time in the view section, we'll create another directory called Fido, and we'll add the view into this directory. And that view will look like this. So we'll ask the user for the device name, and we'll pass along the return URL. Now notice, when we submit from this view, we go back to an action called register. And this is the point at which we register this device in the server. So we need to add that action into the controller. So back in the controller, if I give myself some space, we'll add another action. This time it's going to be an async action. So it'll return a task of action result. And we can import task. And this will be our register action. And this will be passed a reference to that model. Now inside here, I want to know if the model is valid. And if it is, we're then going to manage the registration of this device. And we'll see how we do that in a moment. If it's not valid, I'm just going to go back to start registration, passing along the model. So if we are valid, we need to do a couple of things. We have to initiate registration. And to do that, we need access to Rock Solid Knowledge's Fido component. So back at the top of this controller, I'm going to add a constructor. And into that constructor, I'm going to pass one of the Fido components interfaces. And that interface is called iFido authentication. And I just call that Fido. And then we'll add a field called _Fido into which we pass that reference. Back inside register, we're now going to start the registration process. And to do that, I call _Fido.initiate registration. Now, when we initiate registration, we have to pass two things. We have to pass the name of the device, and we have to pass the name of the user for which we are registering that device. So the user is the first parameter. So we say user.identity.name, and the device name is the second parameter. And we get that from the model. So we can say model.devicename. Now, this returns to us something called a Fido registration challenge. So we can call this challenge, and also we set that equal to this call. Now, this is an async call, so we await on the call. Once we have this challenge, we need to send it back to the browser and allow the browser to challenge the device. So to do that, I need to create a new model. And that model contains information about this challenge. Let's go and create that model first of all. So again, back inside my view models, inside the Fido directory, I'm going to add a new class, and we'll call this class register. Now again, this class will have a return URL, and then this class will need to hold the data to manage the challenge. So to this, we'll create a public property, and the type of this property will be base64 Fido registration challenge. And again, this comes from the Rock Solid Knowledge Fido component. I'll just call this challenge, and again, we have a getter and a setter for this. So to initiate this challenge, we need to send this data back to the browser. So to do that, I first need to create one of these register models. So I say var register equals new register. And then to this, we pass two values. We pass the return URL, and we just get that from the model. Then we also have to pass this challenge value. Now this challenge value we see is this base64 Fido registration challenge. Notice that the return value of initiate registration is a Fido registration challenge. So what we are passing down here is the base64 version of the Fido registration challenge. And to get that base64 version, we can say challenge dot to base64 DTO. And that creates this register for us. And I then want to return that view. And into this view, I'm going to pass this model that we've called register. Now, a couple of more things before I create this view. This function needs to be an HTTP post. And to this view, I need to pass the model that was passed in for us so the user can correct those details. Now, this is the view that's going to interact with the device. And that interaction is going to happen through JavaScript. So I've already created this view. So let's go and see what it looks like. So inside here, out of this register model, we grab the challenge, and I call that FIDO challenge. And I then call this JavaScript function called register. And then we pass a number of parameters into this function. And each of these parameters we get out of this challenge. So we pass in this base64 challenge, we pass in something known as the relying party ID, we pass in something known as the user handle, and we pass in the user ID. And then we pass in this URL, and that's going to act as the callback URL. Okay, so this is the register function and the parameters it takes. So one of the things we have to do here is take string values, such as base64 challenge, and turn those values into something known as uint array types. And I have a helper function, getChallengeAsString, that lets me do that. And if I scroll down here, we can see where some of these things are used. So we have this relying party ID. So that's the server address that this challenge is coming from. In our case, that would be localhost. The user handle is a value that identifies the user. And again, we turn that into a uint8 array. We create a user object that's based on that user handle and the user ID. So once we have all of that data, we call navigator.credentials.create. And this is the code that interacts with the FIDO device. If this succeeds, it returns with some credentials. And we are then going to send those credentials back to the server. And the place we send these credentials back to is this callback URL. So here, we use jQuery and call its AJAX method. We send a query back to this callback URL, and we pass up a JSON version of these credentials. So this callback URL is specified as part of the call to this register function. And in our case, it's /FIDO/complete registration. So we now need to provide that URL. So this URL looks like this. So it's a callback. So it's an HTTP post. And it takes one of these base64 FIDO registration response objects. So let me go and import that. And that's the data that's being passed back from this AJAX call. So inside here, I take my FIDO object and I call complete registration. To this, I pass the registration response, but I need to turn this back from a base64 encoded response into a FIDO response. This is an async call, so I await on it, and I get the result of this, which is an iFIDO registration result. If this is an error, so if we couldn't register the device, then I'm going to return bad request. And the result object provides me with an error description. So I'm going to pass that into the bad request. If we've registered successfully, then I'm just going to return OK. So back inside the JavaScript file, if everything is successful, I set window.location.href, and if anything fails, I just put an error into the browser's console window. Now you'll probably need to handle that differently. So at this point, we should now have a device that's been registered and ready to use. So with that in place, we can run the server and we can run the client. If I click on register, then I'm not authenticated, so I need to authenticate. Click on login, and I can now register the device. So I type in my device name. I'm just going to call this UB, as I'm using a UB key. Click on register, and I now need to interact with the device. So the device has a PIN, as it's storing passkeys on it. So I enter my PIN, click on next, and then touch the device again, and now my device is registered. So that's the first step. So now that it's registered, I can use this to do two-factor authentication. So we do our two-factor authentication as part of the login process. And that's done by ASP.NET Identity. And if you remember, we scaffolded that. So that login is managed by this Razor page, and this is the code behind for that page. And we want to hook into this behavior. So if the user has no device, we want this behavior to stay exactly the same as it is. But if the user has a device, has a key, then we want to use that key to provide two-factor authentication. Now, we can only force two-factor authentication if the user has a device registered, and we only want to check if the device is registered after the user has logged in. So to make our life slightly easier, I'm going to refactor this code and provide a function called doLogon. And into that function, I'm going to place all the code that's inside model_state.isValid. So this is that doLogon method, and it contains essentially the same code as the code that was inside onPostAsync. But notice, this returns two values. It returns an action result, and that's the action we would take normally at the end of this method. But it also returns a sign-in result. And that sign-in result is the result of calling signinmanager.passwordSignInAsync. So inside onPostAsync, we make use of this method. Now for this code to be exactly the same as before, we call doLogon, and then we'd simply return logon result. But it's here that I want to check to see if the user has a device registered, and if they do, force them to use that device, and if they don't, just carry on with the normal logon process. So to do that, I need to use the FIDO component. Now the FIDO component has another interface we use called iFidoKeyStore, and I can inject that into this page. So this interface is called iFidoKeyStore, and we'll call it KeyStore. And then as usual, we'll assign it to a local variable. And let me put these on separate lines. And then back in onPostAsync, we can now change this code to use the device and provide two-factor logon if the device is available. So the first thing I want to do is to check if the login has failed. And we can do that by looking inside its sign-in result. So I can say something like, if not, signinresult.succeeded, then we can return logon result. So basically, if the logon has failed, then go and do what we should do normally on failure. However, if the login succeeds, then I want to reach into the key store by calling getCredentialsIDs for user. So this will return a set of registered devices for a user. A user might have multiple devices registered. So to get that list of devices, we use the email. Remember, we register the devices under that email. Now, if this list is null, or if this list is empty, then there are no registered devices for this user. And in that case, we just do what we would have done normally. So we return logon result. But if we have a device, then we want to force authentication using that device. And to do that, we need to add a few things. So to do the second part of the logon, we have to interact with the FIDO device. And I'm going to do that via the FIDO controller. So here, I'm going to redirect to that controller. And I'm going to redirect to a method called FIDO login on that controller. So we no longer need this logon result. So this controller will be responsible for managing the second part of this login, the 2FA. And it's the same controller we use for the device registration. And we'll see exactly what goes in there in a moment. Now, currently, at this point of the life cycle, the user is authenticated. So if I redirect off to this FIDO controller, they'll still be authenticated, but the 2FA might fail. So what I'm going to do first, before I redirect, is to sign them out. So here I'm going to call the sign-in manager's signoutAsync function. And that's an asynchronous function, so we're going to await on that. Now when I get into the FIDO controller, I still want to know that my user should be there, if you like. So I still want to make sure they are authenticated in some way. So to do that, I'm going to sign them back in, but I'm going to sign them in to a separate scheme. So here, I'm going to call http://context.signinAsync, and I'm going to sign them into this two-factor user ID scheme. Now for this, I need a claims principal, and for that, we need a claims identity. And into that claims identity, I want to put two claims. I want to put the email claim, and I want to put the remember me claim, as we'll use those two claims later in the process. So I have this helper function called build claims, and I'm just going to copy that helper function into this code. Now before we leave this code, I have to do one more thing. I'm signing the user out of the current scheme. I then sign them into the two-factor user ID scheme. If the 2FA succeeds, I'm going to do the reverse. I want to sign them out of the two-factor scheme and sign them back into this main scheme. And to do that, I have to make sure that I call the right endpoint. So on this redirect URI, I'm going to add a URL. Now, at the top of this function, we have passed in the return URL. And this is the URL we have to return to continue the authentication if the user has succeeded to log in. I'm going to pass that URL into the FIDO controller, and then later on, we'll use that URL to continue the process. So to do that, when I call redirect, I'm going to pass along this return URL as a parameter called return URL, but I have to encode it first. And we just use the HTTP utility class to encode that URL. So with that in place, we can now go and add the code into the FIDO controller. So back in the FIDO controller, I'm going to add this endpoint. And it's an endpoint called FIDO login. And notice this takes this return URL, the one we've just set up. So in here, the first thing I'm going to do is to authenticate against this two-factor user ID scheme to make sure that our user here is authenticated and can proceed with the 2FA. So for this, I can say if result.succeeded, then we must have the correct user. Now, if the user isn't authenticated, something has gone badly wrong. So I'm just going to return a new redirect result and then redirect them off to the home error endpoint. If the user has authenticated, then I want to initiate the 2FA. To do that, I need the username. Now remember, we built a set of claims on this two-factor user ID scheme. So I can go and grab those claims, and I can grab the username claim out of the list of claims. I can then call my FIDO component, and I can call it initiate authentication method. And this takes the username. So we're initiating the authentication for this user. This is an async method, so I'm going to await on it, and this returns to me a challenge that we are going to send to the browser. Now, as we did with the registration, I'm going to put this challenge into a model. So back inside the view models directory, in the FIDO directory, I'm going to create a model called authentication model. And this will hold a reference to this challenge. Notice it's the base64 version of this challenge, and it will also hold a reference to this return URL. So back in the controller, I can create one of these models. I set the challenge. Now remember, we can just call to base64 DTO on these objects and get back a base64 encoded version of this object. And we can also pass in the return URL. And then I'm going to return this challenge to the page. So I return a view, and into that view, I'm going to pass the model. Now this page will look like this. We bring in the FIDO.js script again. But this time we're calling a function called complete login inside that JS file. And we're still passing along things like the challenge, the relying party ID. We pass along some keys. We specify the return endpoint. So this is the endpoint that the challenge comes back to when our client-side code is completed, and we pass along this return URL. So this complete login method is similar to the register method that we saw earlier. We pass in these values that are base64 encoded or as strings. We convert these values into uint array values. And then further down, we call this navigator.credentials.get method. This interacts with the FIDO device. And if that interaction succeeds, we get back a result, and we can then post that result back to the server. And we're posting it back to the callback URL, which is this FIDO complete login URL. And if that succeeds, we then redirect to the return URL. Now, the return URL is the URL inside OpenIddict that we're going to use to complete the authentication. And this will be the same URL that we use when we set up the original authentication, so the first part of the scheme. Okay, so what does this FIDO complete login endpoint look like? So back in the controller, we create a method, and it looks something like this. So it takes a base64 FIDO authentication response object, and again, it returns an iAction result. Inside here, the first thing I'm going to do is call complete authentication on the FIDO component. I pass along this authentication response and I base64 decode it essentially. If that succeeds, so if we get result.isSuccess, then I want to initiate sign-in again. But I want to initiate, if you like, the standard sign-in. So similar to the username password sign-in that we normally have. To do that, I need the username and the remember me field. Now remember, we set those when the user authenticated using the two-factor user ID scheme. So if I call http context.authenticate async against that scheme, from that result, I can get back the list of claims. And this is similar to the code that we wrote above. Once I have that claims list, I can get the remember me claim and I can get the username claim. And then once I have the username claim, I can call the user manager.findByName async to get back the user associated with that claim. And then once I have that user, I can call the sign-in manager to sign in with that user. And I pass along this application user and I pass along the remember me flag. Now, regardless of whether complete authentication succeeded or not, at this point, I want to sign out of the two-factor user ID scheme. And then if everything is okay, I'm just going to return okay back to the browser, so back to the JavaScript code. However, if the initial FIDO authentication failed, then I want to return a bad result with some description in the error. And again, that goes back to the JavaScript code. And in our case, we just log that error to the console. So with all of this in place, I should now be able to do two-factor authentication. So if I run the server and I run my client, from the client I can sign in. So I enter my username and the password. And now when I log in, it should ask me to do two-factor authentication. And sure enough, we go off and it asks me to use the security key. So I touch my key, enter the PIN, touch the key again, and we come back to the client page and we've authenticated, and we're also listing out the claims. So we are definitely signed on here. So let's have a think about what's happening here. So in ASP.NET Identity login, inside onPost async, we call do logon, and that kicks off the standard logon mechanism for ASP.NET Identity. If that fails, we just come back as normal. If that succeeds, we see if we have a key by calling getCredentialIDs for user. If we have a key and we have credentials, we sign out of the current scheme and we sign into this two-factor user ID scheme, passing along the email and remember me as claims when we sign into this scheme. We then redirect to our controller and we redirect to this FIDO login endpoint. And we pass along the return URL that was originally passed into this onPost async. In the controller, inside the FIDO login method, we check we're authenticated using this two-factor user ID scheme. If we are, we pull out the claims, and we then call initiate authentication on the rock-solid knowledge FIDO component. From that, we get back this challenge object, and we send that challenge object down to the browser by calling this view method. And we also pass along this return URL we've just got from the login page. Inside the view method, we call complete login. Inside complete login, we call navigator.credentials.get. That interacts with the device. If that succeeds, we post back to this callback URL. And that callback URL is FIDO complete login. Inside here, on our FIDO component, we call complete authentication. If that succeeds, we call authenticate async again against the two-factor user ID scheme. And we call that because we want these two claims from this scheme. We want the username claim and the remember me claim. We take the username and call findByName async to get back the user. And then we take the user and the remember me flag and we call sign-in async on the sign-in manager. We then sign out of the two-factor user ID scheme and we return OK back to the browser. And that OK goes back into our JavaScript file. And that's the success function here. So if we succeed, if we return OK, we then redirect to the return URL. And again, this return URL is the one that was passed into the original logon page, and that's the one that we use to complete our login inside OpenIddict. And if that all succeeds, we end back on this page with our username displayed, kevin@rocksolidknowledge.com, and the claims displayed on the page. And we've successfully logged in using 2FA. So thank you for watching this video. If you want a copy of the source code, you can find it on github.com/Kevin R. Jones/OpenIddict demos -Fido-OpenIddict-2FA.